Hey everyone, it's Chris. Welcome back to another part in the Mario Clone tutorial series. We are going to add some more functionality to our enemy AI script, and if you will remember back from our last tutorial, we've added as much as the enemy being able to check when it's on the ground and being grounded, as well as walking. So that's basically how far we've come so far. And what we're going to do now is we need the enemy to interact with the player somehow, and we also need the enemy to basically be able to walk into walls and know that if it walked into a wall, then it should start going the opposite direction. Okay. So there are a couple of things we've got to do to make that happen. First, we're going to need to create some method to cast some rays either to the left or to the right of the enemy, depending on the direction it's walking in. And those rays need to return back information as to what was hit this time, because, you know, with it hitting the player, we want to know if the player should die based on how he interacts with the enemy. And the best way to do that is have the enemy cast rays and return back information as to what it hit. So if it hits a wall, we want it to go the opposite way. If it hits the player, we want it to send a message to the player that, hey, I just hit you and I want you to die. So that's one thing. And the other part is we need to add some check into our ground checking method to see if the enemy is actually colliding with the player from the top. So like the enemy walking up here on the platform, the player standing here, the enemy falling down on top of the player, that should also signal or send a signal to the player saying, hey, you should die because I just landed on your head. The other part of this is we need to have the player interact with the enemy as well. So because the player is already checking in a downward position, we don't need to add rays for the enemy to check in an upward position to check and see if anything lands on top of the enemy. Since the player is already casting downwards, all we have to do is check somewhere in the player to see what the rays are actually returning, which collider. So we check to see if it's returning the enemy collider. If it is, we'll send a message to the enemy saying, hey, I just jumped on your head, so you're going to be crushed and then disappear because you're dead. So those are the things we still have to do to be able to have the enemy and player interact with each other. So to get started with this, the first thing we're going to do is make sure that we're actually casting some rays from the left or the right side of the enemy. And to do that, we're going to need to open our enemy AI class once again and create a new method. So right below the check ground method, let's create another. Let's create a check walls, and this one doesn't actually need to return anything because we don't need to really update our position, because our position is going to be updated in the update method, so that once a collision is detected on the in the check walls method, it's going to actually trigger the boolean, the left walking left boolean. It's going to change that to false, so that the enemy is going to start walking right. So we don't need to return anything because that method's going to handle that. So in check walls, we are going to pass in our reference position and our direction. Okay. And we're going to create our origin vectors, and then we're going to create our raycast hit objects. Then we're going to create our if statement, and for checking the collider objects for each hit object. Then we're going to finish it up by adding some more conditional logic to figure out which one of our rays actually returned a hit object. So let's go ahead and get started with that. We'll do a vector 2 of our origin top, and create a new vector 2, and position.x plus direction times 0.4 and position and dot y plus 0.5f minus 0.2f okay. Now we're going to do the middle, origin middle, new vector 2, position dot x, and yeah, position dot x plus direction times 0.4f. Now we're just going to do position dot y, already in the center, plus. Right, so vector 2, origin bottom, new vector 2, position dot x plus direction times 0.4f, and now we're going to do position dot y minus 0.5f plus 0.2f. Okay, now we're going to create our raycast head objects. Going to create wall top, physics 2D, not physics material, physics 2D dot raycast, and we are going to pass it our origin top and our direction, which is new vector 2 dot direction, and we're going to pass it the velocity dot x times time to delta time for the length of the rays. And we're going to pass it the wall mask, which we haven't created yet. I just forgot to create these masks. All right, I'm going to create a public layer mask, wall mask. Okay. Pass on the wall mask as our layer mask. Alright, now I'm going to do the same thing for the middle and the bottom. So wall middle, physics 2D, raycast, origin top, no, middle, new vector 2, create direction, 0, velocity x times time delta time, wall mask. Okay. Oh, and I don't know if I explained this before or not, but it's worth mentioning that on the check ground I used vector 2.down for the direction of the ray. For check ceiling of the player, I use vector 2.up to cast the rays up. The reason that I'm creating a new vector 2 here when we're checking the walls is because we're not creating a method called check walls left, check walls right. We're creating one method called check walls. And the direction that we're passing is either a 1 or a -1 based on which direction the enemy is currently moving. So we can use this to our advantage to create this method only once, to actually use this direction to create our new vector 2. So if our if our enemy is moving to the right, we're passing it a direction of 1. So we're creating a vector 2 direction of 1, which is a which is a direction of vector 2 dot right. If our enemy were moving left, we'd be passing a -1, so we would get a -1 in our direction variable. And here, when we're creating our vector 2, we would create vector 2 dot left because it would be -1, 0. So, I just wanted to mention that. Let's go ahead and finish with our last raycast hit object, wall bottom, physics 2D, raycast, and origin bottom, new vector 2, direction 0, velocity x, time delta time, and wall mask. Wall mask. Alright. Okay. You Continuing on, we are going to create an if statement that is going to check wall top dot collider does not equal null, or wall middle dot collider does not equal null, or wall right wall bottom dot collider does not equal null. Okay, so if any one of these doesn't equal null, we've got either a left or a right wall collision. So now we want to get a reference to our hit object, so we create a raycast 2D hit 2D. We'll call it hit ray, just like all the other times, and we're going to initialize it with wall top. And then we're going to do some if statements here to check which one of these has a hit object. So if this one does, we're going to set wall top to set hit ray to equal to wall top. Else, if it doesn't, we're going to check wall middle. And if that has it, we're going to set hit ray equal to wall middle. Else, if that doesn't have it, we're going to check wall bottom. If that has it, we're going to set hit ray equal to wall bottom. Oops, that's wrong. And if that doesn't have it, we are in this if statement by error, so we don't care. We shouldn't be in this if statement altogether anyways, so we just don't care about it. Exactly. So moving on, to make our oops, let's get rid of this parentheses, that doesn't belong there. To make our player, or sorry, our enemy turn around from whatever direction he's currently walking in, we need to give him the opposite direction. So if is walking left, right? Let's say that equals true. Okay. So a way to make that equal false is to make it equal to its opposite. So not is walking left. So now we're turning is walking left into false by passing it not is walking left. If is walking left were already false, then we would give it the opposite of not. So we would then turn it into true. That's easy enough. All right. So now we need to add a call to check walls, and that's simply going to go into our update enemy position, and we're going to put that right here, right after we're checking the velocity. Let's go ahead and just check walls. Oh, and we're passing it position and scale.x. All right. So now our enemy should start walking when it's in view of the camera, and then continue to walk through the player, because we haven't done that check yet. Or wait a minute, it may collide with the player. We'll find out. We will find out. Depending on, actually, let's see here. We got our enemy. And we're going to set our wall mask equal to default. Yeah. Alright, so let's go play here. And oh, it's going to walk right through our player. But it should collide with the wall and come back the other way. There we go. Now we're going to wait for it over here at the pipe, because it should collide with this pipe and then go the other direction. There we go. Perfect. Okay. So it's doing what it's supposed to be doing. All right. And what I was going to show you before is we actually need to go in here in our project settings and go to Physics 2D. And we need to adjust this layer collision matrix. Okay. We want our player. Let's see here. Let's go ahead and uncheck everything. We want our enemy to collide with our player. You guys see that, right? Enemy here, collision with player. Okay. We want our player and our enemy to collide with default. Alright, so what we've got to do here is, because our enemy right now is colliding with the ground, okay? And it's colliding with the walls, but it's not colliding with the player. But we need it to collide with the player when it's going left or right, or when it's falling on top of the player. So for the floor mask and the wall mask, we also want to add the player layer to that mask, okay? Because the enemy should collide with anything that's on the default layer, which is the ground and the pipes and platforms and things like that. And it should also collide with the player. And the same thing for the wall mask. The rays that are checking left and right for the wall mask need to be able to bounce off the player too. So we need to add the player layer to that because that's where our player is. All right. So now if we click play, our enemy should be able to collide with our player, and it should act as though it collided with a wall, so it should start going the opposite direction, which it does. And now it's going the opposite direction again. If we land on top of it, it's not going to do anything because that's something that we need to code in the player class. Okay. Alright, so now we've got our enemy walking around back and forth. So now what we need to do is we need to know if our enemy is colliding with our player, right? And if the enemy does collide with the player, we are going to send the player a message saying that it's game over. Or, you know what? Better yet, we don't need to send the player a message at all. We'll just go ahead and end the game and trigger the game over scene to load. So let's go ahead and add that code. And it's actually really, really simple. So let's go to our class. Okay, enemy AI. Okay. So first, when the enemy is raycasting downward, we want to check and see if it's landing on the player's head. Okay, and we'll check that in here because we know if any of these have collider objects, we know that there are hit objects being returned. So what we'll do is we'll do a hit ray dot collider, and we'll check the collider's tag and see if it equals player. And I'll talk about tags in just a quick second. But just know that this is going to check to see if it collided with the player. And if it did, we are going to application load level game over. Okay. And we need to put this in one more place, and that is going to be in the check walls. So we'll add that in right here. Okay. Right. So tags. So let's go back into Unity, and I'll explain tags to you really quick. If we're here, if we click on our player, you'll see in the inspector at the top here, the tag that is specific to the player right now is actually player. And that's a default tag that is created by Unity. So you'll always have that tag available to you to assign to your player. And basically it just gives him a tag that we can reference him by when we're getting collision detection or collision objects back from the player, that we can call this tag and find out what its name is. The same thing with enemy. Right now enemy is undefined, but we're already going to go ahead and create a tag for him here. Our tag list is simply an array that we're going to add a tag to. Let's call this one enemy. Alright, so now we have to go back and click on our enemy again, and we have to actually select the enemy tag. Alright, so now our enemy is tagged as enemy, which is going to become useful in a little bit when we're going to talk about the player colliding with the top of the enemy. We want our player to check to see if his down collision or down raycasting is colliding with the top of the enemy instead of with the ground. because of course we want something to happen to the enemy when the player jumps on top of him. So now that we have that tag created for the player and for the enemy, and that we're checking what the raycast in the left and right direction, we should be able to have our enemy collide with our player and trigger the game over scene. So let's see if that's going to work for us. And there we go. We are in the game over scene. And we haven't added anything in here yet to restart our gameplay. So basically we're just at a blue screen, and we're going to go ahead and click the stop button here. And so that's working as expected. Alright everyone, that concludes this tutorial, and in our next tutorial we are going to cover what is required for us to allow the player to interact with the enemy, so as to be able to jump on top of the enemy and basically crush them to death. We want to add that in because we actually need to be able to score somehow, right? So that's one way. The other way would be to get our coins out of these question blocks, which is going to be probably the next tutorial after the one that we're doing now, or the one that we're doing after this one. So stay tuned for that, and I'll see you guys soon.